Hey, what's up? So I'm gonna show you the fastest and the most efficient way to graph your linear equation, which is, let's just say, a bit unconventional. You're probably used to something like y equals mx plus b, which is your slope-intercept form. That's a normal form. If you're not familiar with how you can graph linear equations using this formula, you should probably know it by now. I already have a video about it. Link is in the description. Watch it. I go into details. Right now, I'll just quickly recap it. So let's say you have an equation like y equals 2x plus 4, a very simple equation, and at the same time, it looks exactly like our slope-intercept form. We can easily find what our m value is. M is something that comes with x, it's 2, and then b is something that is just roaming free, which in our case is just 4. So we found our b, which is y-intercept, and we found m, which is our slope. Now you can use those values to graph your equation. So b is the point where you begin. It's your y-intercept. So you start from the beginning and you make exactly 4 steps up. Up because it's a positive number. If it was a negative number, you'd go down. So 1, 2, 3, 4. You find yourself here, and this is your y-intercept. When it comes to slope, you should make it a fraction. If you have a whole number and you want to make it a fraction, you just divide it by 1. So in our case, it's 2 divided by 1. Top of your fraction is the amount of steps you should make vertically. It's a positive number, so we go up. 1, 2. We end up here. And then the bottom of your fraction is the amount of steps you should make horizontally. It's a positive number, so we go to the right. Exactly 1 step to the right. And this is where we end up. Now, those 2 points are the points on our line. Since we know those 2 points, we can just connect them. And this is what our line looks like. We just graphed this linear equation. But this is not the only way to do it. This formula is just one of many ways how you can graph your linear equation. Unfortunately, real life is a bit more complicated than this, so you will probably be facing something like 2y minus x equals 3x minus, let's do it 12 this time so that it looks a bit more pretty. This equation looks nothing like what we want it to be, which is mx plus b. It's a completely different form. If we want to use this form to graph this equation, we have to make countless alterations to this equation. But we can also do something different. Now let me clear the area. So remember how I said that your b is something that is just roaming free, separate from your x. That's because you can actually find your b value by setting x as 0, just pretending like x is 0. When you set x as 0, your y value would be the point of intersection with y-axis. I take our equation and I set x as 0. Y equals 2 times 0 plus 4, meaning our y equals just 4. Well, that's our b value. That's how you find your b value. So again, we start here, we make 4 steps up, and this is our y-intercept. Now, let's go to our more complicated equation, and let's remember that we can actually do the exact same thing. We can set x at 0, and whatever y value will be, it's our y-intercept. So it will be 2y minus 0 equals 3 times 0 minus 12. That's right, 2y equals just minus 12. Then we just divide both sides by 2, and we get our y value, which is minus 12 divided by 2, minus 6. That's it. Without making any alterations to our initial equation, we just found our y-intercept. It's minus 6. So let's go back to our graph and let's remember that our b equals minus 6. Now let's find this point. We start from here, and since it's a negative number, we go down. 1, 2, 3, 4, 5, 6. This is our y-intercept. Now, in order to find our y-intercept, we set x at 0. But we can actually do the same thing with x. We can find x-intercept, meaning the point where our line intercepts x-axis, just by pretending like y is 0. So let's do the same thing with our more simple one. Let's set y at 0. So it's just 0 equals 2x plus 4. Let's switch places just so it looks a bit easier. And We subtract 4 from both sides, we get 2x plus 4 minus 4, which is just 2x, equals minus 4. Then we divide it by 2, and our x equals minus 2. This is our x-intercept. Let's find it. We start from the beginning, and we go to the left because it's a negative number. 1, 2. Look, this is the exact spot where our previous line intercepted x-axis. It's a different point, but the line in the end will be the same. It's the exact same line. But instead of finding slope, we just found x-intercept. Now let's do the same with our more complicated example. I'll clear the area a little bit. Let's find our x-intercept. And to do that, we set our y at 0 this time. So it's 2 times 0 minus x equals 3x minus 12. Now it's just a simple equation with one variable that we have to solve. 2 times 0 is 0, so it's just minus x equals 3x minus 12. Now let's add x to both sides. We get x minus x, which is 0, equals 3x. 3x minus 12 plus x. And I will also switch places. 3x plus x is 4x minus 12 equals 0, and then we just add 12 to both sides. So it's 4x equals 12. Our x is 12 divided by 4, which is 3. This is the point where our blue line intercepts x-axis. Let's find it. It will be right here. So we start from the beginning, we go right because 3 is a positive number, and we make 3 steps to the right. We find ourselves here, and this is our point of interception with x-axis, or x-intercept. So we just connect those lines, and that's it. We just found our solution. We just graphed our linear equation without making any alterations, without using the idea of slope. We just found the points of interception. So generally, what you can do when you get any kind of equation, you just solve it when x equals 0, then you solve it when y equals 0, then this is your y-intercept, and this is your x-intercept. And that's it.